During the final stages of construction, we spoke with graduate students Jerod Schwandt and Shaan Stephen about their work designing and setting up the new hypersonic wind tunnel at NC State University.
Hello, I am Jerod Schwandt. I'm currently a master's student in aerospace engineering here at NC State.
I'm Shaan Stephen, and I'm also aerospace. I'm working on my master's now.
Walk us through what happens from tunnel setup to analyzing the data.
For running the wind tunnel, we have a valve that we can open and close and kind of throttle in between from a computer. We open the valve to let high pressure air in from our compressor outside. That air then goes into the nozzle, which due to the shape of the nozzle causes the pressure to drop of the airflow. And when the pressure drops, the velocity increases according to something called Bernoulli's equation. This wind tunnel here, the nozzle will accelerate the airflow all the way to Mach 6, which is 6 times the speed of sound. Once you've done that, the wind tunnel started. And then we start our cameras or whatever tests we're doing, and then that's pretty much it. As far as processing data, we don't just stick something into the wind tunnel, press run, and collect a whole mountain of data that we have to sift through. When we set up an experiment, we try to measure one specific thing. That could be looking at the location of a shock wave, or we want to know what's the surface pressure on our experiment, or what's the velocity, which direction is it going, or what is the shear stress, skin friction on our model. Most of our time is spent just setting up the experiment, tweaking it, trying it out, looking at what happened, and then redoing it if needed. But once you get everything set up correctly, the raw data you get is just that's it. You don't need to do anything to it, or it's very close to what the final project you're trying to get, and you just do a little bit of math or put into a software to kind of get that final result. There isn't a lot of post-processing work we have to do, at least for the experiments we run in this lab. Most of the time and effort is put into setting up the experiments.
What roles did students play in the planning and construction of this tunnel?
Everything you see in red here, plus those two stands, is what I did. In spring 22, when I came into the project, they had a vague idea that they wanted a nozzle, a test section, and a diffuser. And they had a vague idea of what they needed it to look like. Some of the things were planned, like the windows, I was stuck with those. But most of the stuff, there was nothing finalized. So I was the one that came in and finalized all the final design choices, how each section integrated together to form one tunnel. And then on top of that, I was the one that went back and forth in the machine shop and made sure that everything could hold a vacuum, everything could withstand the pressure. I was selecting the materials that they were made from. And then after that, once everything was manufactured by the machine shops, I was the one that coordinated transporting everything to this facility, hooking up to the air pressure, and then actually assembling them together.
So what I did mostly was focused on the controlling side of it. So I was looking at trying to find a pneumatic valve to control our airflow, find regulators to make sure we can regulate the pressure down to a safe level, and the nitrogen supply systems, and a little bit of work with the heater system for the wind tunnel. Shaan did all of the actual tunnel stuff. I was more on the side of making the control systems, how do we turn it on and off safely.
What material is the wind tunnel made from?
The test section is made of steel, I know that. The walls are 1/2 inch thick, just some steel. The windows are actually manufactured, I don't know who manufactured, but they're made for submarines. That's how they can withstand all the pressure. I don't remember about the diffuser and the nozzle, really.
I believe it's aluminum, based off of how light it was when we tried to pick it up.
Yeah.
What opportunities are available to students interested in hypersonic research at NC State?
So generally when you're working aerodynamics, you either work on experimental or the numerical side. Numerical is computer simulations. We pretty much solely focus on experimental side of things here. If you're at NC State interested in experimental supersonic and hypersonics, you would be working in this lab. We're the only lab on campus that has supersonic or hypersonic wind tunnel. We've had a lot of grad students and undergrads come and work with us. Some, like Shaan, come very often and will stay here for many years and do a lot of great work. Some will come every once a week, just kind of lend a helping hand because they're interested in seeing what you're doing. We've also had people come from outside of the mechanical and aerospace engineering department. A couple months ago, we had someone from the nuclear engineering department come because they were interested in supersonic aerodynamics. We haven't had someone come from outside of the College of Engineering, but it's not entirely out of the question. A lot of the stuff we do in this lab is about setting up for experiments, and that's not something that's taught in class, that's something you learn by being here. So anyone who is interested can come and say they'd be interested in coming to help out.
Yeah, Dr. Venkat especially, he's pretty inclusive. So if someone just sends an email, which is what I did, he just says, come take a look at the wind tunnel by yourself. If you like what you're doing, I'll give you something to do. And so I looked around, found something interesting, and he said, okay, go do that. And it was pretty easy. I'd say for just the hypersonic tunnel itself, there's probably about 7 or 8 people that worked on that one project alone. And we have probably like 9 or 10 projects at this point.
Yeah, a lot of different people contributed to this project. It's not just the 2 of us. There's also, I know, a few other professors and labs around on campus that do computer simulations of supersonic and hypersonic aerodynamics. Dr. Edwards runs a pretty high-tech CFD lab. I see his name mentioned in a lot of papers. I know others do it. I don't know exactly everyone though, but if you are interested in the numerical and computer simulation side of aerodynamics, there are a lot of labs at NC State that you can join.